Welcome back to Site Unreliability Engineering, the series where we're exploring how complex systems work and also how they inevitably fail at the same time. In this episode, we'll be exploring different requirements for understanding complex systems. In particular, the different data types and instrumentation techniques we can use to understand how systems are actually working in production and ultimately use that knowledge to operate them in a better way. We know that the amount of data we have from our systems is ever increasing. We've got new data types, new metrics, a mountain of log data. And from there, we can build pretty complex visualizations and understandings of what's actually going on. But the truth is, when we look at this mountain of data that's ever increasing around the systems we operate, we realize that it's not a silver bullet. In particular, having more data doesn't actually automatically make you better at running or designing systems in the first place. The goal with this mountain of data is to actually understand what's going on inside a system. Turns out there's a really reasonable term for this, and you may have heard it already. It's called observability. With observability, the idea is we want to measure how well we understand the work our system is actually doing. Ideally, we want to increase observability of our system in the first place. Observability is an important concept, especially with complex systems. There are two classic approaches to understanding what kind of work a system is doing. The first and classic approach is black box monitoring. With black box monitoring, you treat the system as a black box. You have no idea what's going on inside the system or what the inner workings are, but you do know whether it's healthy or unhealthy. With white box monitoring, you're actually able to see inside the system. In particular, with white box monitoring, you're able to actually understand more about the inner workings through this idea of instrumentation. Instrumentation, of course, is measuring events inside of code. The traditional approach of black box monitoring in combination with the white box monitoring ideally helps increase your knowledge of what the system's actually doing in the first place. In doing so, you increase the observability of your system. When we consider white box and black box monitoring, we often think of what kinds of data those monitoring systems are actually emitting in the first place. Three really important types of data are now popularly known as the three pillars of observability. The three pillars of observability are metrics, logs, and traces. Metrics are just a measurement of some event. Logs are human-readable events. And traces are some relationship between different events. It's the combination of all three that we can use to increase observability. Consider a ship hitting an iceberg in the middle of the North Atlantic Ocean. We can describe this event in several different ways. First of all, we can have different human-readable representations of that event taking place. We can have someone writing down in a logbook what time the ship hit the iceberg. We can have a measurement of how many icebergs the ship hit during the journey, a metric. And finally, we can have a trace or a relationship between all the different related events that took place that caused the ship to hit the iceberg in the first place. When we talk about systems and observability and the three pillars, we're ultimately using different sorts of data type for different types of events to increase our understanding of what actually happened with the system and understanding how it works. Even with great observability of some components of a large system, inevitably some parts will just get less attention. We call these the here be dragons components of an architecture. With a very large architecture, over time, it becomes very common for knowledge to shift from older legacy components to new tools, processes, and frameworks. This is pretty common as people move to new job roles and work on new projects. At the same time, there's still a hard dependency between new things and older legacy components. This presents a serious challenge to understanding how an overall system works, especially one that's composed of different types of components. In our next episode, we'll be exploring how to address some of these challenges using instrumentation.